Welcome everybody. Tonight's online Foxpro user group presentation is going to be done to Hennig. He's going to show us unit testing in VFP applications. I think most of you probably know Doug, prolific speaker, writer on Foxpro, Stonefield Database Toolkit, Stonefield Reporter, all sorts of stuff. Turn it over to you, Doug.
Alrighty, well, thanks, Todd. So this session is going to be on unit testing Visual Foxpro applications. One of the things that I started thinking about in the last couple of years is that unit testing is something that's not really well known in the Foxpro community. It is in other communities. There are dozens of testing frameworks and tools available, but it's not something that just for some reason just never got a lot of traction in the Foxpro community. There haven't been a lot of sessions at conferences. There's not a lot of white papers, not a lot of articles in magazines or other places. So hopefully this session will try to turn that around a little bit. So what we're going to look at in this session is why unit testing is important and what it's good for. What is a unit test? We'll talk about the principles of good unit tests as opposed to bad unit tests. We'll talk about some things like how to name and design unit tests, how to use a testing framework. We're specifically going to look at FoxUnit. We'll talk about what dependency injection is and how it comes into play with testing and how it can help. We'll talk about how you can use mock objects, both with both manual and an automatic one, including a tool created by Christoph Vollenhoff called FoxMock. And then we'll finish up by talking about some guidelines for writing good unit tests. By the way, you have to excuse me, I have a cold, so I'm probably sounding a little bit nasally right now. So let's talk, first of all, a few reasons about why unit testing is important. The first one is that it helps to ensure that your code matches your specs, assuming that you have specs, of course. But specs often say that when an invoice is posted, the tax should be calculated this way, and maybe an email sent to the sales manager, and it should be posted to these tables, and so on. Well, you can ensure that it happens sort of the manual way by adding an invoice and going look in the table and seeing if an email was sent and manually figuring if the tax calculations were done. But with unit tests, you can ensure that happens because you write tests that make sure that the values are being stored properly and so on. It's also really useful for finding bugs because, after all, a unit test is essentially a client of your software. So it exercises the things that your software is supposed to do, including things that might not be done very frequently, like, say, month-end or year-end processes. And so this can find bugs because, after all, if there's a bug in the program, anything that runs it is going to find it eventually. It's really useful for adding or changing functionality. For example, let's say that you want to add some new capabilities to your invoice posting routine, such as maybe getting a currency rate from a web service or something like that. Well, how do you know that adding that functionality won't break something else in the program? Unit tests, you can make sure of that because you can have some tests, run them, add some new functionality, and all those old tests should still run the same. You'll have to write some new tests for the new functionality, but all of your existing tests shouldn't be impacted by changes that you've made. Related to this is refactoring. Sometimes folks will clean up their code. For example, you might have a lot of code in the UI of a form and decide that maybe it's better to pull that code out and put it into business objects or things like that. Well, how do you know that you didn't accidentally misplace some code or some of the functionality is no longer there because you just didn't copy and paste it right or it's not being called from the right place anymore? Well, again, with unit tests, you can, before you start refactoring, you can run your tests. Then after the refactoring, those same tests should work just fine to make sure that you didn't break something or drop something and so on. One of the things that I find is I'll write a code with an API or an interface of some kind. I don't mean a user interface, but I mean like the methods that you call and the parameters you pass them and so on. And they seem like perfectly reasonable methods until you start writing some tests for them, and then you realize, well, geez, these methods are kind of hard to call. What I have to pass 50 parameters. Maybe it would be better if I did it a different way. I was actually about this last week, that he finds that when he starts creating some tests, he realizes that he's got too much code in his forms and not enough in his business objects, because now when he tests his business objects, he's not testing the entire functionality. And that's how he discovered that, oops, I left some code back there. It also helps when you're bringing in new developers. Sometimes an application might be very complex, and to have them come up to speed by going through every single facet of the application might be hard on them. So if instead you have them be responsible for, say, running some unit tests and going over the tests, by looking at the tests, they can see, okay, well, this particular method must be doing these 5 things because there are 5 tests for it. Then each of them does, test one thing, and so it might be a way to get new developers up to speed. So now that we talked about why unit testing is a good thing, let's talk about what a unit test actually is. There's a book that I highly recommend called The Art of Unit Testing by Roy Osherov. And he defines unit tests like this. A unit test is an automated piece of code that invokes the method or class being tested and then checks some assumptions about the logical behavior of that method or class. So let's break this down a little bit. It's an automated piece of code. In other words, it's not going to be something that you're going to necessarily be running manually. It's something that should be run as an automated process. And it's going to be code as opposed to you banging away at the keyboard to try and test it to see how something works. It's going to call a method or check some properties of a class, and it's going to then check some assumptions about that. So in other words, you will pass some parameters to a method and check the return value, or you'll check to see whether a record was added to a table or modified, or whether another class got instantiated, things like that. Whatever the class is supposed to do, you will check to see whether the class actually did that. So here are some of the principles of good unit testing. First of all, they need to be automated, as I mentioned a moment ago. So the idea is that I shouldn't have to go to my command window and type a bunch of stuff to go and run some unit tests. Because if I do have to do that, then chances are I won't do it because it's just too much work to get those things launched. I should be able to run these things with a click of a mouse or typing a single command to run a bunch of tests. The tests must be repeatable. That means that if I ran them yesterday and I didn't make any changes to the code, I should get the exact same results today. If they're not repeatable, then that means that there's something wrong with the test or something kind of flaky about the code. And the problem then is that you can't trust the results if you can't repeat them. And again, if you can't trust the tests, then you won't be using them because it's kind of a waste of time. Tests need to be easy to implement. That means that if a test takes more than a few minutes to write, if it takes you longer to write a test for some code than it took you to write the code in the first place, then you're not going to do it because it seems like a waste of time. You're doubling your development, the time it takes to develop your application. So you just won't do it. So that means that tests have to be quick and easy to run or to write so that you'll actually be encouraged to do it. They need to be available for future use. This isn't going to be, you're not just writing it for a one-time run. You need to be able to run these things in the future, because if you don't, then you can't use them for things like checking to see whether refactoring that you've done worked or not. Anybody needs to be able to run it. If the test only runs on my machine because the code's there and it's all the plumbing is there and all the infrastructure is there, then the problem is if I'm on vacation or I get hit by a bus, then nobody else can run the test to make sure that they work. Everybody needs to be able to run the tests, which means the tests have to be placed in an environment that allows them to be run anywhere. The tests also need to be run quickly. If it takes 2 hours to run a suite of tests, then at the end of the day, when you're supposed to be running your tests, you'll probably decide, well, you know what, I'll run tomorrow, or I'll run them next week. I'm sure they'll run better next week. So they need to run quickly. That means they don't do a lot. They just do certain small amounts of things just to test a little bit of your code. So let's take a look now at what we would do to create some tests. So I've got, switch over to Foxpro here. I've got a little class here called log file processor. It really doesn't do anything yet. It has a single method called isValidFile. You pass it a file name, and it just does a bunch of things to make sure that the file name is valid. For example, it was passed as a character string and it's not empty. It has to have a log extension. The file has to actually exist, and so on. And if any of those things fails, then an error message gets set, the error message property gets set, and the method returns false. So like I said, it's not really doing anything else yet right now, but it's just a very simple little class. So then I wrote some tests for this class that test the behavior of that method. So we're going to start by erasing a log file. That's going to be used as the file for this test. We're going to instantiate the class, and then we'll call isValidFile name, isValidFile with no parameters, which should fail because it wasn't passed as a character string. The same thing passing an empty string, which should also fail because It is not allowed to be empty. And of course, we're checking for that sort of the opposite. We're expecting that this thing will return false and that the error message is set to one of these strings here. If it doesn't return false, if it returns true, that means that the test actually failed, right? Because it failed to see that it was an invalid parameter. So we're going to test for all these different conditions: a valid extension, a non-existent file, and so on. So let's go and run these, and all the tests passed. So that was pretty straightforward. Let's try something else here. Let's go and change the code here so that it actually has to, the name of the file has to have a log X extension. And if I go on the test now the fourth test failed because it actually passed in log as the extension, and it needs to be log X. Let's go and change this back. Let's make one other change to the test. We're going to add another condition now to our code. I'm just going to uncomment this. By the way, I'm using Thor as sort of a quick and dirty way. Instead of having to right-click and then choose this, Thor has some functions for commenting and uncommenting code, and so I just assigned a hotkey to them. And so that's a quick way to uncomment this code. And I'm going to do the same. Let's just save that. And I'm going to do the same thing over here. I'm going to comment out this test because this one would fail now. So let's just comment that one out. And I'm going to uncomment a couple of the other tests that I had here. And so what these tests check for is that we have to make sure that the log file, this new code, not only checks that the file exists, it also checks that it actually is not empty as well. And so this code here should fail because we're just writing an empty string out to the log file. So this one should fail. Here, this one should pass. I mean, the test will pass because we're specifically making sure that this thing returns false. And the last one here is we'll actually create a log file that has some text in it and make sure that it returns true. So if we run that, now all tests will pass as well there. So that's our first quick and dirty test crack at writing some tests. There are some problems with these tests. First of all, they can't be automated. The reason they can't be automated is because at the very end, a message box appears indicating whether the test passed or failed. So there has to be a human being there to click on the OK button, which would be a problem if I want to be able to put this on a server or run this at night and so on. It's also looking for hard-coded strings. It's looking for invalid file name in parentheses or in quotes and so on. So that's probably not a good idea as well. Also, the tests can't be run individually because they're run, the code is one long linear set of code. It runs them all every time I run that process. So let's take a look at maybe what would be a better way to do it. First of all, the tests should be independent. That means they're not, you're not running them one after the other in a particular order. You should be able to run all the tests or one test or four tests or whatever. Another thing we might do is log the results somewhere rather than displaying them in the UI. For example, we could log them to a file. We could put them into a cursor or a table, whatever we want to. So let's go and take a look at another example here. These ones are called Better Log File Processor. And here, I'm going to either open or create a table that will hold our test results. And then we're going to run our tests. So the tests are actually now put into individual little programs or into little functions. So here's one, for example. We instantiate the class. We call the isValid file with no parameter, and then we do it again with an empty parameter. That's test number 1. Test number 2 checks to see whether we have a valid extension or not. Test number 3 checks to see whether the file exists or not. Test number 4 does the same thing, but this time we actually have a valid file, and so on. Test number 5 makes sure that the file isn't empty, or checks to make sure it's empty or not. So we have some infrastructure in here. I have a function called log result that all of the other methods call that simply adds a record to the cursor indicating what the test was and what the results were. So all of these functions are going to call that log result when they do their thing. So if we run this now, here is the results. We've got it. Let me just size this so we can see the results a little better. So here are all the results, and you can see actually that I've run this numerous times before. I ran it back July and then back in November, and again earlier today, and then again now. And so we can see all the different results. So this kind of shows you a history of when these tests were run, and you could maybe analyze this in some way, like which results return false. Now we have to go back and maybe look at the test, maybe look at the code, see what's going on there. But anyway, so this is an example where this could be automated now because although I did bring up a browse window, I didn't have to. We could have some other process that checks to see whether all the tests run today have a result of true, and if not, do something about that, like send an email to the lead developer or something. Now, there are still some problems with this. First of all, if we want to run individual tests, we still have to change the code. They are individual little routines now, but what calls them is do test 1, do test 2, do test 3, and so on. We'd have to go and change it yet again if we want to be able to run just individual tests. Also, the names aren't very useful. Test 1, test 2. The name of the test isn't really telling us what that test is doing. You'd actually have to read the code for the test to see what it's testing for. There's also potential for some duplicated code. You notice that in every test, I had to instantiate the object, call log result. So I'm doing a lot of the same things over and over again. And finally, we have to maintain the infrastructure. In other words, I had to have some code that created or opened the table, that logged the results, and so on. All that was manual code I had to write for the tests that are there. So let's take a look at a few ways to resolve these issues. We'll start with naming tests. It's a good idea to have a naming convention for your tests because it will allow it'll make it a lot cleaner and easier. But also, if you just look at a test name, you can tell exactly what methods it's testing and what kind of behavior it's testing. Otherwise, you have to read the code. So typically, the recommendation is that you'll use for your test program or module is it'll be called class name test. So in this case, because it's the log file processor, my test would be log file processor test. That would be my PRG or my module or whatever it is that contains all my tests. Individual tests would be named method name underscore scenario underscore expected behavior, where method name, for example, in this case is valid file. Scenario would be something like we're passing an empty string, and the expected behavior would be returns false or fails or something like that. So by having names like is valid file, when passed empty string returns false, you can tell exactly just by looking at the name of the test what that test is testing and what it's doing without having to read the code to see what the test is supposed to do. Typically, tests are laid out what's called a triple A, arrange, act, and assert. So if we look at the test 4 that I had talked about earlier, the first couple of lines are considered to be arranged lines. In other words, you're setting things up. Here, we're going to create a file that we're actually going to use as our log file. Then we're going to instantiate the object that we wanted to test. So those are arranged lines, setting things up. Then there's the act statement or statements, which is where you actually call the method that you want to test. So in this case, this one line here where we call is valid file. Finally, there's assert, where you check the results to see whether, what the return value of the method was, or whether a record got added to a table, or whether an email was sent, or whatever it is that this method does. You check to see whether it did what it was supposed to do. And in this case, we're calling this that log result function, and we're passing it whether it succeeded or not. So if we take a look at, go back to Foxpro here. If we take a look at the even better log processor and take a look at it now. So one of the things I did in here was to change the method, the names of the test methods or functions, so that way they're more obvious. Is valid file, no file name returns false. Is valid file, invalid extension returns false. Is valid file, returns true. And so the rest of the tests, one of the changes that I made was I pulled out the common code of creating the object into one method. One of the benefits for doing this is because later on, if for example, the init method of this class accepts some parameters, I'd have to go to every test and make sure that I pass those parameters. Whereas if I put the instantiation to a single place that all the test methods call, then if there's some parameters required or some other kind of setup, like setting a couple of properties before I can use it, I can do that all in one place, and I don't have that duplicated code in every method. And so now the method's a little more straightforward. We call our helper method to instantiate the class. So here's our act. our range. Then here's our act, where we actually call the method. And then here is our cert, where we check to see whether the method was, or the return value was what we expect it to be. So this all doesn't resolve the issue about being able to run a single test, because again, we have a sequential set of do statements, but we're getting a lot closer to something that looks like a reasonable test. Becoming smaller, we're pulling out the infrastructure and putting it in common places, and we're giving much better names to our tests as well. Are there any questions at this point?
Rue's got a question in the chat here.
Oh, where do I have to go to see that?
I've got that open for you, so I can.
Oh, okay. Oh, I see it now. Okay.
Once he gets it typed. If anybody else has a question, we don't have too many people tonight. You can turn your mics on and ask away, or type it in the chat window. Rue is typing a long question, apparently. Or he's a slow typist.
Well, maybe we'll move on, and then once he's finished typing, we'll come back and address that question.
Okay, yeah, if any questions come up in the chat window, then I'll grab your attention, Doug.
Okay, yeah, I actually didn't have it open. I've got it open now, so I can see it there. Okay, so so one of the ways that we can resolve some of those other issues, but having to write our own infrastructure and how do we run individual tests and so on, is by using a testing framework. A testing framework gives you a couple of different things. First of all, it gives you some infrastructure. The tests are typically going to be methods in classes that are going to be subclassed from the framework test classes, and they'll have some behavior in them, as we'll see in a couple of minutes. The other thing that you get is you get typically a user interface to allow you to manage a suite of your tests, clicking by or running a test by just reviewing the results, package them all together in one place, and so on. So a framework gives you some things that make it a lot more convenient for running your tests and even creating your tests than it would be if you had to do them manually like I was doing before. There are lots of frameworks available for other development environments such as .NET, Java, and so on. And Unit is a very popular one, for example, and it's available on a number of different platforms. Frameworks like it are available on a number of different platforms. So about 10 years ago, Jim Irwin and some others from VisionPace, including Drew Speedy, created a Foxpro-based testing framework called FoxUnit. They modeled it after NUnit because they had some experience with that, and it seemed like a reasonable thing to do. About a year ago, or maybe not quite, Eric Selje decided that this might make a great VFPX project. And so we contacted VisionPace, got permission from them to create it, to turn it into a VFPX project, and has done some tweaks. I think he took some of the code that Alan Stevens had worked on, a few changes to it. And so he took some of that code, made some changes of his own, and it's available now as a VFPX project. So the way that we get to that VFPX project, let me just find my desktop here. If you go to the VFPX home folder, eventually, well, for some reason, VFPX doesn't seem to be doing much for me. So anyway, if you go to the VFPX home folder, vfpx.codeplex.com, you will see that there are, cancel that. You'll see that there's a bunch of projects listed, and FoxUnit is one of the projects there. There's a couple of ways you can install FoxUnit. One is you can download it manually from the VFPX site, but there's actually a much easier way, and that's if you're using Thor. It's actually one of the tools that can be installed automatically by Thor. So if you go back to Foxpro here, and if I fire up Thor, or choose Thor, under the Thor menu is check for updates. If you choose that function, and we may have the same problem that I had. Oh, no, I guess it's working okay. All right. So what this does is it checks to see whether there are any updates to VFPX projects you've already installed, or even projects you haven't installed. So for example, I've already installed FoxUnit, and you can see that there aren't actually any updates for it. Otherwise, it would be automatically checked and it would say update available. But if I hadn't installed it, it would appear a little bit further down the list under the not installed section. So to install it, all you do is put a check mark in front of it and click on Install Updates, and it will go through and download FoxUnit, install it on your machine, and now it'll be there. After you've installed it, it actually installs under the Thor Tools menu, Applications, and you can see it's here. Oops, Thor Tools, Applications, and here's FoxUnit, and then here's the FoxUnit class. I've actually assigned a hotkey to it, so when I hit Control-Alt-F, that will bring up the FoxUnit UI automatically. So now let's talk about how you create some FoxUnit tests. Now that we've got FoxUnit installed, how do we go about creating some tests that use that framework? So let's go and do just that. I'm going to go and launch it by hitting Control-Alt-F. So here's the FoxUnit UI. It has across the top a toolbar of buttons. These ones over at the left here are for running tests. These ones here are for managing tests. For example, creating a new test class, loading an existing class, adding a new test to an existing class, removing tests and modifying tests, and so on. You can also do some searching. So for example, if you have a lot of tests, you can do some filtering by typing in the class name or the name of a test, and then it'll filter the list so you only see those tests. Down here in the grid is where you see a list of the tests that you already have. Sort of at the top level, the ones that are not indented is the name of the PRG and your first test. The ones that are indented under it are additional tests, test methods inside that PRG. So you can see I've got actually 3 of them, this one here, and this one here. It also shows you the results of the most recent run. So you can see that I didn't run this test here, or these tests here, or these tests here. They're shown with sort of a gray background, so they haven't been run. These tests here I did run, and because they show a green background, that means that they all succeeded. If any red background would be shown, that means a test failed. For example, if I go and run all tests, I actually do have a few failing tests here, and we'll get into we'll fix those tests or fix the code to make them work later on. But you can see it ran all the tests. Most of them succeeded, some of them failed. And if I click on a particular test, I can see why it failed. It'll show me exactly what happened and so on. I can either run all the tests that I have all together. I can run all the tests in a particular class, or I can run just a selected test. So if I click on this one test here and then click on selected, it'll just run that one test. What I want to do is I want to create some new tests. So let's go and create a brand new class. Now, by default, FoxUnit is going to put these tests in the tests subdirectory of your project folder. So if we switch over to Windows Explorer here, you can see that this is where I'm sitting right now, and there's a test subdirectory, and this is where the tests and some of the FoxUnit support files are actually stored as well. So that's why they're already filled in here as the folder. I can change that if I want to, but we'll stick with that for now. And I'm just going to give it a generic name like X. Now, we could choose the test template that we want to use. So let's start with the standard one and see what that looks like. So let's choose, and there's some other choices here as well. Do you want the methods to be named as procedure method name or function method name? Just depends on what style you like to use. Do you want the methods indented by one tab or not? So after you've picked the template you want to use, you then click this button here to go and create your test class. Or you can choose this to do your own template, or just click on this one to copy an existing one. We'll just click on this button here. And so this is what it creates. It created a PRG called X in that test subdirectory. And you'll notice that it uses the same name as the name of the class. And you notice that this is going to be a subclass of this class within the FoxUnit framework. We'll go through some of the things that are in here in a little bit, but you notice there's lots of comments. So here's a description of some properties you might define and what they're for. Here is the setup function, here's what it does, and some examples of how you might use it. Here's the teardown method and what it's for and how you might use it. Lots of example comments. That's how you might create a test. Let's go and create another one. We'll call this one Y. And this time we'll choose the minimal test instead of the standard one. And the difference really is that it gets rid of all those comments. It still has some comment lines, but really just as a separator around the method names. Other than that, all the other comments are dropped. Let's get rid of some of these things here. And let's go and add a new one. This one I'm going to give a real name. We'll call it log file processor test. Because remember, I said that the naming convention for your test should be the class you want to test. In this case, we're testing the log file processor class, and followed by test or tests. I like to use just the singular word test, but it's up to you. The third choice I'm going to choose here is a custom FoxUnit template. How this got in the list is because before, when I used it, I clicked on this button here. That brings up a dialog where you pick a PRG, and that PRG is basically going to be used as the template. Once you've done that the first time, then from then on it adds that to your list here, so you don't have to click it and find it every time. You just, you can select it from the list and then click this big button here to go and use that template. So here's a template that I've created. If we switch back to Windows Explorer here, SF unit test template, it is a template that I've created for using my unit tests. So let's take a look at a few things here. Like I said, it names the test class the same as the PRG, so they're sort of convenient. This bit of code here is there so that IntelliSense works. So that's why they're defining this is a little trick here. Local this as basically this class, and because it's in these pound defines with a false, it won't actually get compiled, but it is there for IntelliSense. So here in this method, for example, I can say this dot and get full IntelliSense on, so I can see there's some assert methods and there's a setup and teardown and some other properties and all kinds of other things in the test framework that I can use, and that way I get IntelliSense on that kind of stuff. This property here, iTest prefix, if you add some helper methods, like let's say, for example, I'm going to have a helper method that will be, say, instantiate my test class. I'll say instantiate class, and it does something like, new object, yada, yada, yada. So what will happen is that other than the setup method and the teardown method, which we'll talk about in a minute, that FoxUnit knows about, every other method it will think is a test method, and so it'll run it as if it was a test. Well, for a helper method like this instantiate class, it's not a test method. It's there to assist or support other test methods. I don't want this one to be run that way. So by setting this ICTest prefix to test, that means only those things starting with the word test will actually be executed. So in other words, all my tests would be named something like test is valid file underscore no file name underscore returns false, or something like that. So only those things that start with a prefix of test will actually be executed as test methods. The other thing here is this OObject to test. This is something where you can instantiate that object into. So in fact, rather than having an instantiate class method, I actually like to use the setup method for that. Setup method is called before every test method executes, and teardown is called after every test method executes. So I can do something like this. I can say this dot O object to test equals new object, my log file processor, yada, yada, yada. I'm not going to type all of this, but okay, I've got some code I'll show you in a second here. But that way now, and in teardown, I might do something like, clean up after that object, and then null it, and so on. So in all my tests, I can now, rather than having to instantiate that object, it's already been instantiated. So now I just have to say this dot O object to test dot is valid file and pass some parameters and so on. Okay. So now I don't have to go through have that infrastructure of having to instantiate it, having a helper method, and so on. There's already a helper method here called setup, and so we can use it for that. So let's go and get that code here, and I'm going to go and grab some existing code and just copy and paste it. And go back to my FoxUnit window. Now this is kind of a goofy thing about FoxUnit, and hopefully I or somebody else will change this. That is, if you create a test, the PRG gets created, but if there's no actual test methods in it, then you get this warning message. I think that's probably unnecessary, really. But anyway, so let's go and copy and paste this in here. Okay, so here's my code. So as I mentioned before, the setup method simply instantiates our log file processor class. Teardown erases the log file. So some of our tests are going to create a log file. We don't want that log file kicking around later on, so we're going to erase it again afterwards. And so that's what the teardown method does. So here's my first test. Test is valid file, no file name returns false. So now I just have a couple of lines of code. We're going to, because OObject.test already contains an instance of the log file processor, I just have to call as is valid file method. So all my tests do that and just pass different parameters. Then we want to see whether the method worked or not. So in that case, I'm going to call some of these assert methods. So this dot assert false means I want to make sure that this value, this expression, is false. If it isn't false, that means the test is going to fail. And then we'll know that, that's either the test is wrong or the code behind it it's calling is not doing what it's supposed to do. So all these are pretty much test falses except for this last one here, where we're going to assert true. So in other words, if everything about this method worked, then this method will return true, and so we want to assert true. We want to make sure that it in fact returned true like it's supposed to, meaning that that test succeeded. So if we go and run this now, I can either run an individual test by clicking on selected, or I can run all of the tests in this test class by clicking on class, and you can see that they all passed. Or I could click all to run all tests in my entire set. Any questions about anything so far? No? Okay. Then let's go back to here. All right, so there are a number of different assertion methods. It'd be something like this dot assert something. So assert false means that the expression that you pass it must be false, otherwise the test fails. Assert true is just the opposite. Assert equals actually gets two parameters, an expected value and the actual value, and then you're going to assert that they equal each other, otherwise it fails if they don't. Assert not empty does just that. It asserts that the expression does not give you an empty value, like an empty string or false or a blank empty date, things like that. Assert not null asserts that the thing that you're passing in is not null. Assert not null or empty means it can't be either null or empty. All of these assertions have an optional message parameter, in which case you can pass it something like, maybe the thing that you're testing or a message about why it may have failed or something like that. And so if you use that and it fails, then that message will appear in the UI as the message about what went wrong. There are some assertions I think that are missing. For example, there really should be opposites of everything. We've got false and we have true. We don't have a not equals, which means that you kind of have to maybe check for the opposite of these two things. Maybe for some reason if they're supposed to be not equal, then you have to kind of jimmy the results to make sure that they're not equal, or that that they are equal, so equals passes or fails. There should be an empty, there should be a null, and so on. So there really, like I said, needs to be the opposite of every condition, so you can check either that it is equal or not equal, it is empty or is not empty, it is null or is not null, and so on. But anyway, that's that's something that can be added to the framework. Oops. Went too far. There we go. So let's take a look at another class called new log file processor. It's actually going to collaborate with a helper object. So let's go and take a look at that. Where's my Fox? Here we go. Let's just close FoxUnit. We can close this guy. So here is my new log file processor. And it has that same is valid file method that the other one did, but now it's got a couple of other things. It has an parser object or property and an n log type. And we've got a method in here called import log that actually is going to do something this time. It's actually import a log. You specify the name of the file that it should import, and then it's going to do one of two things based on the n log type property. If it's set to a 1, that means the log file is an XML file. So we want to be able to support multiple different types of log files. Maybe it'll be CSV, maybe it'll be XML, maybe it'll be a curse or table, maybe it'll be something else, and so on. So here we've got a couple of different choices: an XML log file parser and a CSV log file parser. So depending on the setting of n the log type. Either way, it gets instantiated into this oparser object. And then we call the oparser parse file method, passing it a file name. And then if that returned true, then we'll carry on and we'll process the file. Otherwise, we'll get the error message and so on. And if we take a look at these helper methods, here's an abstract class. It doesn't do anything other than having a see error message property and a parse file method. Here are some concrete subclasses of it. This one is the CSV file parser. So its parse file method will create a cursor and append from the log file into that as a delimited file. The XML file parser class uses XML to cursor to read in an XML file into a Foxpro cursor, and if something went wrong, will return false and send an error message and so on. So, like I said, this new log file processor class is now collaborating with another object. Now, let's take a look at a FoxUnit test for that. I've got one down here. So if we look at this test class, it's similar to the other one that we had before. So we're in our setup, we're going to instantiate the new log file processor class. And here I've got a method, test import log, import XML returns the correct value. So you can probably tell what it's going to do. It's going to be importing XML rather than CSV, and assuming the XML was well formed, it should return the correct value. So here is the arrange part of our test. We're going to create an XML file that has some log information in it, and then we're going to call the import log method of our object, and we expect that it'll return a 2. Here's what it'll actually return. We expect that it returns a 2, and then we call assert equals to make sure that it did, in fact, what the expected value is the actual value. If the test fails, then whatever the error message was from the object, we'll assume that something went wrong, and we'll display that as the error message when this test fails. So if I go and run this one test here, it succeeds. So far good. The problem is that by testing the import log method, we're actually testing the helper class as well, because you can't separate the two. When you call import log, it instantiates either the CSV parser or the XML parser and calls its parse file method. So really what we're doing is integration testing, not unit testing. We really just want to test the import log method to see if it does what it's supposed to do without necessarily relying on whether the import log or whether the helper class it collaborates with works or not. In fact, I may not have written the XML or CSV parser yet. So how can I test import log if the thing it's supposed to collaborate with doesn't even exist yet? I can't. I have to wait until some other class is done before I can test, I have to wait till class B is done before I can test class A, which is kind of goofy. So the solution to this issue is to use a mock object in place of the real object. So let's go and take a look at, before I talk about that, we should actually talk about a little sidetrack here and talk about dependency injection. So one of the issues that we have with that import log method is that it hard codes the class that it's instantiating. So we really can't do anything about it. So you notice here, when we call import log, it instantiates one of these two objects here into this.oparser. So we really don't have any choice. We cannot substitute a different class for either of these two because, there's no other method that's called before import log. It just, it's all part of the one thing. So, and that's a bit of a problem because it doesn't allow us to use a mock object. Oops. So let's talk about dependency injection. Wikipedia defines dependency injection as a software design pattern that allows the removal of hard-coded dependencies and makes it possible to change them, whether at runtime or compile time. So breaking this down, what that means is that we are not going to have a hard-coded dependency. We're not going to instantiate a class where that class name is specified in quotes, meaning it's hard-coded and there's no way to change it. And by doing that, that allows us to specify a different class under different conditions. Obviously, sometimes we'll want a CSV class and sometimes an XML class, but sometimes we may want a mock class that really doesn't do anything, just so that we can make sure that the class under test works. Now, so that's called dependency injection, when rather than hard coding the class you want to instantiate, you inject that class into the class under test. Usually it's the client that injects the dependency, and there's a bunch of different ways you can do that. And you probably have done some of this yourself without knowing that it was called dependency injection. One is to set a property. So for example, we can actually do that. If we go back to here, I've actually got some commented out code. And let's uncomment this. Oops, got my Thor. And we'll comment out this. Okay, so now this import log method expects that somebody set this.oparser to an object. And if it doesn't, it'll fail. So that means, and you notice that nowhere now in this class are we actually setting this.oparser to anything. So that means that this thing relies on whatever client wants to call it to do that instantiation and setting that property. So the benefit now is that the client the client knows what kind of parser it wants the log file processor to use. The log file processor has no clue, and nor in this case should it. So that's one way, is you can set a property. Another way is you could pass it to init instead. So in the init method of the class, you'd pass in the object that you want to instantiate. The init method would say something like this, that oparser equals toparser, and then that's all you need to do there. That's sometimes called constructor injection, mostly because the .NET framework init methods are called constructors instead. Another is to pass it to the method it's used indirectly. So in other words, what I would do here is I do something like comma toparser. Excuse me. In that case, I wouldn't need this code here either, other than maybe checking to make sure the toparser was an object. And then I would use toparser. So that way I don't have to, it's not a member of the class. It actually just, in this case, it gets passed into the method. The downside of that, of course, is that if I'm using the oparser object from more than one method, I have to pass it to every method that's used in, and that can be kind of a pain. So that's why properties are more often used. The first two actually are by far the most common ways that dependency injection are used. Passing to a method is another one, but a little less common. Something that I actually use a lot, if you've ever looked at some of my code, you see that I've actually used this mechanism, this fourth mechanism a lot. And that's where I've got properties that contain the name and the library to use. So I might have something like, this dot C class to instantiate is log file or XML file parser, and this dot C library to instantiate is the name of the VCX file or the PRG that contains that. And so in my code, I then say this.oparser equals new object, this.c parser class, comma, this.c parser library. And then that way, the client object just has to change that property change the C parser class property to the name of the class it wants this thing to instantiate. So like I said, I used to use that a lot. I don't so much anymore now that I know that there's an official term for this kind of thing that I've been doing called dependency injection. I tend to use the first two mechanisms, but I've used that fourth one a lot. Something that a lot of Foxpro frameworks use, like Visual Fox Express and some of the other ones, is to use a class factory instead. So rather than having the client instantiate it, the class the helper class you want it to use, it'll call a class factory and say, give me a file parser, and the class factory has been configured to say, okay, I'm going to give you back the XML one or the CSV one or a mock one if that's what it's supposed to do. So in that case, it's the class factory that's responsible for instantiating the object and giving it back to the class that is going to actually use the object. So now that we've taken our little detour about dependency injection, let's talk about mocks. So a mock is I'm using the term mock, by the way, as a generic term. There's actually subcategories of these things. There's mocks and there's stubs and a variety of other things. I'm going to just label them all mocks. The idea of a mock is that it has the interface, and by this I don't mean the user interface, I mean the properties, events, and methods of the replaced object, but it has either little or no behavior at all. In other words, it's sort of a fake. It looks like a CSV file parser because it has the same C error message property, and it has the same parse file method that accepts the same parameters and returns a true or a false or whatever, but there's no code in the method. So it doesn't really do anything. The purpose of a mock is to allow interactions between components without the overhead or the complications that the actual class, the class we're mocking, might have. For example, in a more complicated scenario, a helper class may, for example, use SQL pass-through to create a SQL connection to a SQL Server database and get some data and close the connection and so on. Well, what if the database doesn't exist? Or what if I don't have the ODBC driver installed on my machine? Or what if I don't even have that class designed yet? There's more complications and more overhead involved with that thing. Whereas our mock should be very lightweight. It really shouldn't do anything because we're not testing the behavior of the helper object. We're testing the behavior of the class that uses the helper object. Obviously, we'll write tests for the helper as well, but that's not what we're doing right now. We're writing a test for log file parser or log file processor. And so we don't really need to test whether the parser is doing its job or not. And as I said, the other component may not even exist yet. I may want to test my log file processor when I don't even have a file parser that's been created yet. So let's go and take a look at what the BFP here. Let's go and take a look at a Fox test for this. Use a mock. So that's the next one here. Here we're going to, as I said, because we're going to set a property, that's the type of dependency injection we're going to be using here, we're going to instantiate a mock file parser and put it into the OParser property here. Then we're going to call import log, and we'll check to see whether we got our expected result back or not. And here's the definition of the mock file parser. So it has the same interface. In other words, it has that C error message property, and it has a parse file method that accepts the same parameters. But in this case, we're not parsing any file. In fact, all I'm doing is I'm creating a cursor and appending a blank record to it and returning true. In fact, and this one actually has a little bit of behavior only because the parser or the processor class expects that the parser creates a cursor of some kind. Other mocks might have no behavior at all. This method might be completely empty other than returning true or whatever it is it's supposed to return. So if we go and run this test now, this one also succeeds. But like I said, it didn't actually go and do any parsing because this thing doesn't do any parsing at all. It just creates a cursor and appends a blank record, and that's all it does. So now the benefit is we're testing the import log method of the file processor without worrying about what the parser has to do. Any questions so far?
No questions yet, doesn't look like.
Okay. Now, this was, that was a pretty simple class, right? I mean, it just had the one property and the one method. And in fact, if I'd subclassed the file parser class, if I said define class mock file parser as file parser, then I wouldn't have had to manually add the C error message property and so on. But even so, if you have a lot of helper classes, or some of them are fairly complicated, it can be kind of a pain to have to go and build up these mock classes, because it's some work. And if the interface for the class that you're mocking changes, you have to go and change the mock as well. Otherwise, now maybe your tests will fail. Other development platforms like .NET have mock frameworks. For example, the .NET, there's a bunch of them. I happen to use Rhino mocks, for example, as a tool for automating the creation of a mock object, so you don't have to manually create one. A couple of years ago, Christoph Vollenhoop created a tool that's like this for Foxpro called FoxMock. He presented it at Southwest Fox last year, so if you were at the conference or have access to the white papers, you might want to go and take a look at his presentation from last year where he talks about that. I'm going to show you just a brief look at Fox. We're not going to go through it in nearly as much detail as Christoph did. For this, we're going to take a look at a little bit more complicated class. So let's look at this biz object now. So this is a business object. In fact, this is going to be a customer business object. It has an O connection property, and this is going to be now an object that knows how to talk to the database. Because the idea is this business object may not necessarily work against a SQL database. It might just be against a Foxpro local tables, or it might use a remote view, or it might use SQL Server, or it might use Oracle or Access or whatever. And this class shouldn't know that level of detail, right? It simply knows that it collaborates with a connection object, asks it to connect, asks it to execute a SQL statement, and deals with that. In fact, I don't even have a connection class. Like I said earlier, sometimes I need to be able to test this business object. It collaborates with a helper object, but I just haven't gotten around to writing the helper object yet. So how can I test this thing? Well, I can do it with a mock. So like I said, we've got this connection property. This one, just for grins, I decided to use that constructor injection, or in other words, passing the object that I'm going to be collaborating with to the init method, and it will store it here. So that way I could, for example, have made this protected so that nothing outside this class can talk directly to OConnection. You have to pass it in as part of the init method. So I just did that for grins. So here's a method called getCustomer. You pass it the ID of the customer that you want. It calls the connect method of the connection object. If it failed, it's going to set the error message property to could not connect the database, and it'll grab the C error message property of the connection object. So this means obviously that connection object has to have this property, and that will be our error message so that we can pass it on down the line. If the connection succeeded, then we'll execute a SQL statement where we'll go and get from the customer's table, we'll go and get the person with the ID that the method was passed to. If that worked, we'll go and do a scatter name, and we'll return that object. Otherwise, we'll set the error message to record not found if we didn't find it. Or if the execute method failed, then we'll say SQL statement failed, and we'll get the error message of the connection object. And either way, we'll return either null, or we'll return that business object containing properties if it succeeded. So that's my biz object. Let's go and take a look at some FoxUnit tests for it. So as part of my setup, I've done a couple things here. I've added an OMock property now, and I'm going to instantiate FoxMock into the OMock property. So you have to have foxmock.prg in your local drive or in your path somewhere. And then we'll instantiate that to OMock. And then of course we'll instantiate our object under test into OObject-to-test. And a tear down, we're not doing anything fancy. So here's our first test. GetCustomer can't connect. So if the connection object couldn't connect, we should return null. So now I could manually create a connection object, but we want to automate that using FoxMock. So now here's the syntax for it. I'll show you the whole syntax, then I'll break it down one at a time. So we're going to create a connection object by asking FoxMock to do that, and we'll come back to this one. Then, now of course, because I didn't pass it to the init method, I'm actually setting the OConnection property. So here we're going to do that, and then we're going to call getCustomer, and we're expecting that this is going to return a null object because we're expecting that the connect method is going to return false. Now, how can we be sure that the connect method is going to return false? That's what this whole thing, this long thing here does. So let's go through this one at a time. So this .omock is talking to FoxMocks. .new means I need to create a new mock object. And I'm now, with the rest of the statement, going to define what that mock object looks like. It should have a property named CErrorMessage, and that property should, with the is method here, should have the value cannot connect. Now the reason for the double quotes here, this double quote and the single quote, is because this thing expects to be passed an expression that it's going to evaluate. In this case, I just want a hard-coded string, so that's why I have to pass it inside of quotes as well. So this creates a property called CErrorMessage, and it's going to have the string cannot connect. And I'm also going to it's going to have a method called connect, and this method is going to return false. So what this whole one statement does is it creates a brand new object with a CErrorMessage property containing the string cannot connect, and it contains a connect method that when called will return false. So now when we give that mock object to our business object and call getCustomer, if we look at get customer and we see that connect returns false, that means that this method here should return null, because if we couldn't connect to the database, we're going to return a null object back. Here's a similar method, but this time we're going to allow connect to return true. It's just that execute will fail. Maybe, for example, I pointed to a database that doesn't have a customers table. So that in that case, the execute method will fail. So again, get customer, can't execute, returns null. So again, we're going to ask FoxMock to create a new object for us. It'll have a property called CErrorMessage that will contain cannot execute. It'll have a connect method that will return true this time. However, it'll have another method called execute that will return false. So then I give that object to my object to test, and I call get customer. And again, this thing should return null for a different reason this time. And that's because although connect succeeded, this time execute failed. And so again, I should get a null object back. I would have a different error message coming back. You know, if I were to check the CErrorMessage property of this.oObject, I'd have a different reason than the last test, but it will still return null. Here's another one. So again, we're going to call get customer. And assuming that connect succeeds and execute succeeds, but if I've got no records, in other words, I don't have a customer with that ID, then we're going to return null as well. So again, we're going to ask FoxMock to create a new object. We're not going to bother with the CErrorMessage property because we're not going to do anything with it this time. We're just going to have a connect method that returns true and an execute method that returns true. It doesn't do anything. It just returns true. So again, we give that object to our object to test. We call get customer, and once again, we're going to make sure that it's null because I created a little cursor here and didn't put any records in it, and so there are no records returned by that method. This time, assuming that we find a record, we should return an object. So this time we're going to do our setup by creating a cursor and just sticking some dummy value into it. We're going to create our FoxMock's method, or our FoxMock's object with connect returning true and execute returning true. And this time, we should not have a null object because we did have a little cursor that contains something. So when we did a scatter name, it would have succeeded. And then we have another method that's, again, kind of similar here. So if we go and run these tests, they all pass. So like I said, the nice thing about FoxMock is that I don't have to, I'm not doing any integration testing because I'm not relying on the behavior of my helper or my collaborating object. And in fact, I don't even have a collaborating object. I didn't even create one of those things yet. I haven't gotten around to writing it yet, but I can still test my business object without having one of those things. So that's kind of the beauty of having those mock objects. Any questions? No questions? Okay. So let's talk about a couple of other concepts related to unit testing. You may have heard of this thing called test-driven development, or TDD. The idea is that you actually write your test first, then you write your code. So in other words, it's test-driven. So you actually start by writing a test that fails. And the reason it would fail is because there's no code that it's calling yet. So obviously, the test is going to fail. So you write a test that fails, then you write the code that allows the test to pass. So I write a test that says, you know, instantiate my business object class. Well, business object class doesn't exist, so therefore that test is going to fail. So now I have to create a business object class. So I'd say define class business object and define, has no code in it. So now my first test was simply instantiates the object, succeeds. Now I run another test. Maybe we write a test that calls the get customer method. Well, that's going to fail because there is no get customer method. So now I'll go back to my business object class and I'll add a get customer method that maybe just, you know, returns a true. And now my test will pass. Then I write another test that, you know, passes a certain parameter to get customer and expects a return value. That test will fail until I go and write some code in my get customer method so that the test doesn't fail. And you keep on doing this over and over again until all the functionality in your specification is covered. And in other words, if your specification says that when get customer is called and passed the ID of a customer that doesn't exist, it returns null. If it passes the ID of a customer that does exist, it returns an object that has properties representing the fields in that customer table filled in with the values for that customer. So you write some tests that test that functionality, you write the code that makes those tests pass, and now you've got a complete business object until you've got more, until the specs change, and now you've got to add some more tests and some more code that does it. So there are a lot of people that use test-driven development. I tend not to, or I shouldn't say tend, I don't use test-driven development because it's not really necessary to take advantage of unit tests. However, what I do is I write tests almost immediately after adding a new method or changing the functionality of a method. For example, earlier today, I added a couple of lines of code to a method of a class. I immediately went and wrote a test that to check the functionality that I added to that method to make sure that it worked, and therefore I made sure that I didn't have any bugs and there was no syntax errors and it did what it was supposed to, and so on. So it's not exactly test-driven development, but by making the unit test come very shortly after the code that was changed, it's sort of similar, I guess. How do you test your user interface? The issue is that it's a lot more complicated to test UI code than it is to test non-UI code. Testing business objects is relatively straightforward. Testing a user interface is not, because how do you simulate that the user clicked the OK button, or that they typed something into a text box, or that they chose something from a menu? It's a lot more difficult. There are some commands built into Foxpro that will allow you to do that. For example, you can say your test could do mouse at and then some coordinates to simulate moving the mouse over a particular part of the form. Or you could keyboard something. Or you could do things like say, my class under test dot text box name, txt name, dot value equals, to simulate the user typing something into that text box, and then saying form to test dot command OK dot click, and so on. So you can simulate that. The problem is it creates relatively fragile code, because relatively fragile tests, because especially with mouse at, if you move a control around, or if the user resizes the form, or well, I guess it wouldn't happen in our test, but if you move some of the UI around, now you're not clicking the same spot anymore. You have to go and change your test every time you change your form. So there's a lot more setup and a lot more testing code needed, and the code tends to be a lot more fragile than it would be for non-UI code. But it is possible to do it if you want to. Of course, this brings back the whole idea that maybe there shouldn't be much in your UI. Maybe your UI should be bound to business objects and almost no behavior in the UI whatsoever, because then you really don't have much to test after all. So that's probably a hint that would be a better approach. How do you test legacy code? So, okay, this sounds great. I'm really fired up about unit testing now. So if I write a brand new application from scratch, I know I'll definitely be using FoxUnit. What do I do about the applications that I've had for the last 15 years? I mean, it seems like a good idea to write some tests for them, but, so where should I start? Well, it is a little bit difficult, or can be difficult, to write tests for legacy code. One reason is there may not be what you might call seams. In other words, when you're writing code that is going to be unit tested, you tend to write these things as more components, right? They're not mushed together. There's not much integration. You try to write them as individual components because you got to test them as components, so you might as well write them as components in the first place. Legacy code wasn't typically written that way. You've got a lot of code in the UI probably, and there's a lot of dependencies between classes, and that makes it more difficult to write tests. Another thing is that, okay, well, if I don't have any seams, maybe I should refactor my code so that way I can write tests that will work. Well, the problem though is that, if the only reason you're refactoring is so that you can write some tests, that kind of seems like an expensive use of your time. Unless the testing is extremely important, like you've got problems everywhere, it's failing in lots of places, and the tests are going to help you. if your application pretty much works and you want to add some tests to it, it does seem like a waste of time to do refactoring just so that you can write some tests. On the other hand, if you try to refactoring without any tests, that's kind of risky, right? Because if I start moving code around, it's possible that some of the code got lost, or now the meaning's changed, or the parameters are different, or the environment's different, or it's not set up the same way, and now maybe stuff is going to blow up, or worse, it won't blow up, it just doesn't work the same way, and you have no way of testing it because you don't have any tests in the first place. So that's a complication. Another question is, where do you start? I mean, if you got a big application that does accounting or pharmacy or things like that, do you start with the reports? Do you start with data entry? Do you start with processing functions? Where exactly do you start? And more importantly, who pays for it? If this is something that you're using internally, then maybe it's a cost you're willing to absorb. But if it's a custom application for a client, how willing are they to throw a bunch of money at you that doesn't get them any new functionality? It just means that you can confirm that the application does what it's supposed to do. Well, isn't that what they paid you for in the first place? If it's a vertical market application, then that's probably a little bit different. Maybe you're willing to spend some effort into writing tests for it because you've got 1,000 customers and you'd rather not have 1,000 problems. 1,000 customers with problems. So one place that you might want to start is with some integration tests. Although this topic has been on unit tests, you might start with some integration tests. In other words, okay, let's test the year-end functionality. Let's call the code that does the year-end processing. Maybe we'll set up a database that has certain records in it. We'll call the year-end process, and then we'll check the results of, maybe there's some new records in the database, or maybe some records got summarized, or, a bunch of stuff happens. You'll check to make sure that what you expect is actually what happened. And that might be a place to start, especially if it's going to be something that you're planning on adding a functionality to or refactoring anyway. Then that seems like a really good place to start writing some tests for. If it was the year-end processing, for example, that you were going to maybe add some functionality to, write some tests for it first, make sure it works the way it's supposed to, add the functionality, run those tests again to make sure that they continue to work as such, and then write some additional tests for that additional functionality. Any questions about anything I've talked about? No? Okay, then just a couple things more and then we'll wind up. Some guidelines for writing unit tests. First of all, keep your tests simple. A test should only test one thing. A lot of times, in the past, I've kind of, well, I'm calling this one method and there are two things that are kind of related, so maybe I'll just test them both and save myself having to write two tests. And that never works out. It's always better to write two tests that test one thing. And in fact, the next point is kind of related to this. If you have to have more than one assertion, asserting that one result is a certain way, and another result is that way. If you find yourself writing more than one assertion in a test, that's a hint to you that you're probably testing too much. So make sure that you test only one thing at a time, and that you assert only one thing, that a certain result occurred. Even if your method does multiple things, have one test for each of the things that the method does, and have your assert do one thing at a time. Test that the invoice was created, and another test that the email was sent, and test that the client record was updated. Those are three things that the one method does, so write three different tests for it. Use descriptive names, as we talked about. Avoid logic in your tests. If you find yourself writing ifs or do cases or scans or things like that, that's a hint to you that your test is probably too complicated. And the reason that you want to avoid logic in tests is because now if your test fails, why did it fail? Did it fail because you have a bug in your test, or did it fail because you have a bug in the code being tested? Now you've got two sets of code you have to debug, and that's really kind of gets away from the purpose of debugging unit testing in the first place, that you want to test your code under test. So like I said, if you find yourselves using ifs or cases or scans or things like that, those things all are points of failure. So if you find yourself doing it, you probably need to write other tests. Another thing that's really hard to do, but you should do it, but you'll probably find yourself not doing it, is to test what the code is supposed to do, not what it does. And by that I mean, it's so easy to look at the method that you're testing, see all the things that it's doing, and write tests for those things. Well, the problem is, if you do it that way, you're really testing what the method is doing, not necessarily what it's supposed to do. If you look at the spec, that tells you what the method's supposed to do without defining how it does it. Your test code should probably do the same thing. Your test code shouldn't really know how the method does what it does. It should just know what it does and test that. Like I said, this is kind of a hard rule to follow because we're all human and we want to test what this thing is doing. We have internal knowledge of the method and we want to test that the internal things are doing what they're supposed to do. Probably the best solution to this problem is have somebody else write the test. I wrote the method, you write the test for the method, and you don't look at the code. You treat it as a black box. You look at the spec to see what the method's supposed to do, and you don't look at the code and you write the test based on that. But of course, that assumes you've got people that just write tests, and that typically doesn't happen. So use helper methods to eliminate duplication. For the most part, I just use setup and teardown. But if you've got other things that not all tests do, because setup and teardown are fired for every test, so they should only do things that every test requires them to do. But if you have some common other things, like say 4 tests need to do something else, then create a helper method that. Don't duplicate the code. Create a helper method and have those 4 tests call that helper method instead. Make sure that your tests run in isolation. Boy, I tell you, there's nothing harder to track down than a test that runs fine by itself, but when you run all the tests, it fails. That should be a hint to you that there's probably some dependency between tests. Like if test A runs before test B, it works, but if test B runs before test A, it fails. Or if test A works when you run it by itself, but if you run A, then B, then C, somewhere along the line, test B is failing. So that probably tells you that some expectation of the test or of the class being tested is being set up by one of the tests that ran earlier and not cleaned up. So that's why you should use your setup and tear down methods to make sure that you create a file that maybe is being tested, and then you delete the file afterwards, so that when you run the next test, that you're, or if you, if test A creates a file and test B expects the file doesn't exist, you should maybe make sure that you delete the file in the method that created the file, or in the test that created the file, so that way you clean up after yourself, so other tests aren't gonna have that impact of, oops, A ran and did set some things up that B wasn't expecting. Don't tolerate failing tests. It's especially when you're under pressure to deliver your application to your client, it's easy to say, well, you know what, this test failed, but I know why it failed. It's not really that big of a deal. I'm going to ship to the client anyway because it's not really a problem for that test to fail. Well, it is. I mean, if the test failing is okay, then what's that test doing there in the first place? Tests should never fail. You shouldn't ship anything to a client. You shouldn't maybe check in your code that other developers might trip over until all of the tests pass. So that's a rule that we have at Stonefield, is that we use Mercurial for our source control, and the rule is if you get a single test that fails, you're not allowed to commit your changes until all those tests pass. If you do, the other developers are going to mock you and tell you that you are a bad developer and give you heck and so on. All right, any questions?
Any questions from anybody? Chat window, or open your mic if you like. Doug, I think I'm having a little trouble taking it from the example to the real world, maybe.
That's definitely, I can definitely see that. And that's the kind of thing where you kind of need to do it.
Okay.
I mean, and probably the way that, since unit testing is new to most people, I'd start with something new if you can. For example, I'm about to create a new class for my application. So let's write some unit tests for that one class. Let's forget about the rest of the application. Let's just do them for this one new little piece that we're adding. and worry about that, and then we'll worry about maybe other tests.
Would you, like talking about that biz object that you had there? I mean, would you really write a class that tested if your connection worked?
If it's part of the behavior of if we go back to that class, I mean, back to here, typically in your code, wherever you've got some branch going on, you need to create a test for the branch succeeding, the branch failing, right? I mean, if this connection can fail,
Yeah.
and I get into here, I need to be able to test to make sure that I handle that case. And I need to handle what goes on in here. So, I mean, this was a contrived example, really. In a more real world example, you might not, be doing that kind of thing here. But you do need to check for that is without looking at the code internally. If the spec said, if this happens, then we'll do this. And then if this happens, we'll do this. And if this happens, we'll do this. You need to test all of those things that can happen and the results of all those things. So yes.
That it actually behaved correctly.
That it behaves correctly, exactly. And if the behavior is the connection could fail, then if that's part of the method here, then you should probably test for that.
That it should.
We did have a couple of questions here. Kevin actually made a comment that if you're not using Thor, that the FoxUnit page on VFPX has got a link there if everybody wanted to see it. So Marty asked a question: how can you migrate from unit tests to integration testing? I haven't done a lot of this myself. Mostly what I've done is individual unit tests. Integration testing comes in where now, rather than using a mock object, you actually are going to instantiate the connection object. So at this point, I actually do have, maybe my connection that talks to SQL Server, my connection that talks to Foxpro data, my connection that talks to Oracle, and so on. And so I might have a test where I'm connecting up my SQL Server connection object to my biz object, and I've got a sample SQL Server database. Maybe I would create the database as part of the test, populate it with some records, tell the biz object to use the SQL Server connection object, call the get customer method, make sure that I got back what I put into the database, and then tear it all down by, maybe deleting those records or deleting that test database and so on. So the integration testing means now testing the bigger scope of things, making sure that these things that these things are working together as a collaborative unit rather than just the individual pieces. Phil asked, how much of this have you used on your legacy code versus new code? I've used not very much at all on legacy code for the reasons that I kind of outlined, that your legacy methods tend to be big and kind of monolithic, and it's really hard to test monolithic stuff without refactoring it into smaller pieces and then refactoring. If you're refactoring only so you can test, that is, it's kind of hard to make that business case why you would do that. So the truth is, I haven't done a lot of legacy code testing. I've done a lot of new code testing, but not a lot of legacy code testing.
Any other questions? Okay, thanks a lot, Doug.
All right, well, thanks everybody. Well, hopefully this will prompt you to maybe give FoxUnit a try. Start, playing with unit testing, and maybe spread the word a little bit. Maybe at your user groups if you have them, or if you're getting together with other developers, maybe talk about why unit testing would be a good thing in the Foxpro world, as it has been for many years in other environments. So that's it.
Thank you.